Now in this video we're going to talk about a thing called rationalising the denominator. When we deal with surds, with fractions, we like the denominator of our fraction to be a rational number. So we don't like having square roots on the bottom of a fraction. We want to try and get rid of the square root off the bottom of the fraction. So how do we do that? Well, surprisingly, what we do is we multiply through by 1. What does that look like? Let me give you an example here. How about if I gave you the number 6? If I multiplied it by 1, I haven't changed its value at all. But I could multiply that by 1 in a different way. What if I took the number 6 and multiplied it by the fraction 2 over 2? What would that equal? Well, 2 divided by 2 is just 1. The answer would still be 6. 6 times 2 is 12. 12 over 2 hasn't changed. My 6 stays as 6. Why? Because I'm multiplying through by 1. I can take my 6 and multiply through by anything I like. I can multiply by 10.4 over 10.4. It's still going to equal 6. I could go take my 6 and multiply it by the square root of 3 divided by the square root of 3. It's still going to be equal to 6. It isn't going to change its value. So you're probably thinking, well, what's the point of timesing through by something that equals 1 if we don't end up changing the value? And that's the key point. We don't want to change the value. We want to keep 2 over root 3, whatever value it comes to, we want to keep it that value. So the way we work around this is as follows. Now, we're going to multiply this through by a value of 1 so that the overall value of the fraction doesn't change. This is how we do it. I have the square root of 3 on the bottom. So what I'm going to multiply through by is the square root of 3 divided by the square root of 3. So I've multiplied through by 1 because root 3 on root 3 equals 1, so I'm not changing the value of the original fraction. But what benefit does that give me? Let's have a look. Timesing fractions, you just times the top two numbers, so 2 times root 3 will be 2 root 3. Then on the bottom, the square root of 3 times by the square root of 3. From the work that you've done in previous exercises, you'll know that that is equal to 3. I've rationalised the denominator. Instead of having a surd on the bottom of my fraction, I now have a rational number on the bottom of my fraction. So whatever surd I have on the bottom, I just multiply top and bottom by that, and my surd disappears off the bottom. If you type 2 root 3 into your calculator, and this 2 root 3 over 3 into your calculator, you'll find they are exactly the same answer. Let's try a second example and see what it looks like. I want to get rid of the surd off the bottom. So the surd is root 20. So I'll multiply the top by the square root of 20, and I'll multiply the bottom by the square root of 20. The top line now looks like 2 root 3 times root 20 is going to be 2 root 60. Root 20 multiplied by root 20 is 20. From there, 2 on 20 cancels down to 1 over 10. Now, pause the video, have a go at simplifying the square root of 60 and see what it comes to. Have a go, and we'll see if we agree with one another. Did you get 2 root 15 as the simplification of this? If you did, very good. So, this fraction here, which is messy and ugly and has a radical on the bottom, if I'm going to rationalise that bottom number, will end up being 2 root 15 over 10. Plug this in your calculator, get an answer. Plug this in your calculator, get an answer, and you'll find they're the same answer. Rationalising the denominator is a skill that we need for grade 11 and 12 Maths B. One more style of the question. Let me clear the board and I'll show you what it's like. Let's have a look at this one. Instead of having just a plain square root on the bottom, I've now got square root of 5 plus 3. We have to handle that slightly differently, and there's a very, very simple and easy way to handle that. Just watch up here for a moment. If I gave you this situation, let's say I gave you, say, the square root of 2 plus the square root of 3 in a bracket, and I times that by the square root of 2 minus the the square root of 3. That's going to expand to an interesting and very useful situation. Pause the video, have a go at this, see where it leads you. Expand this bracket out, and then see if we get to the same answer. When you expanded it, did you end up with this? Using the FOIL method, first, outside, inside, last. When I multiply the first elements, root 2 by root 2 is root 4. The outside ones, root 2 by negative root 3 is negative root 6. Then the inside ones, root 3 by root 2 is positive root 6. And then the last ones, root 3 by negative root 3 is negative root 9, which of course simplifies down to square root of 4 is 2. They add out to be 0. Square root of 9 is 3. So final answer, negative 1. There's a pattern that's happening here. I had the square root of 2, and when I expanded it, I ended up with 2. I had square root of 3. When I expanded it, I ended up with 3. This setup up here is what we call the conjugate. If you have exactly the same numbers in the bracket, but one bracket is plus and one bracket is minus, we call them the conjugate of one another. The end result is whatever is that element ends up being squared to produce that. Whatever that element is ends up being squared to produce that. Because it's multiply, it doesn't matter which bracket you put first. You could have the takeaway bracket first, and once again, that element squared produces the 2, and that element squared produces the 3. We're going to use that idea over here. So because we have two numbers added together, I'm now going to, on the bottom, multiply through by the conjugate. So on the bottom it's going to be root 5 minus 3, and on the top, root 5 minus 3. So once again, same top and bottom, I'm multiplying through by 1. How does that help us? Well, over here, this is the pattern that we're following. If I expand the top line, that top line is occurring twice, so it's going to be 2 lots of root 5 minus 3. And then on the bottom line, the pattern was, whatever one element inside the bracket is, you square it to produce this number. So, square root of 5 squared would be 5. From it, we now take away whatever the second element was, you square it to produce this element. Well, we don't have a square root this time, I just have a plain number. Same pattern applies. I square the 3 to get 9. That's my bottom line. My answer is now 2 outside of root 5 minus 3 over negative 4, and we just tidied that fraction up. Just move the negative from the bottom to the top. 2 on 4 cancels down to 1 over 2, and then the bracket that stays there, square root of 5 minus 3. Rationalising the denominator. So one's like this, where you have two numbers add together on the bottom, or you can do it with two numbers subtracted together. You multiply through by what we call the conjugate. And when you multiply by the conjugate, that pattern eventuates. Whatever the first number is, you square it. Whatever the second number is, you square it, subtract them, and you have got the expansion of the conjugate. Right, I'm going to put up 2 questions to practice to get you into class. Show me these when you come in and we'll see how you're travelling. Here are your 2 entry-level questions. Show me these when you come into class. Just rationalise the denominator. This one, just multiply top and bottom by this. Here, just multiply top and bottom by the conjugate. See you in class. Let me see how well you've done.